Let's make a video, number 55, 3x cubed. So I'm hoping for three nice binomials with a 3x, an x, and an x. That gives me the 3x cubed and a 2 on the end. So we want to do synthetic division to check for 1s and check for 2s. Because of the 3 up front, we may have to switch over to long division and check the 1/3 and the 2/3. Okay, let's hope not. 1s. Three comes down. 1 times 3 is 3. Add that, you get 7. 1 times 7 is 7. That cancels that out. 1 times 0 is 0, but it doesn't cancel that out. -1. 3 comes down. -1 and 3 makes -3. I add, I get 1. -1 and 1 makes -1. I add, I get -8. -1 and -8 do not cancel the 2. That gives you a 10, actually. Try the 2s. 3 comes down. 2 times 3 is 6. We'll add, we get 10. 2 times 10 is 20. That gives us 13 when we add. That's going to give us 28. Nope. -2. 3 and -2 gives me -6. Oops. That's my next thing. Bring the 3 down. 3 and -2 gives me -6. I add, I get -2. -2 and -2 gives me 4, which makes that -3. -2 and 3 gives me, but that doesn't cancel, that gives me an 8. So we have to switch gears and do long division. If we're going to check for positive 1/3, that means you want to divide by 3x minus 1. You need to have a 1 that you can add over and a 3 that you can put under. That gives you the 1/3. If we're going to check for -1/3, we'll be dividing by 3x plus 1. 2/3 will be 3x minus 2. -2/3 will be 3x plus 2. Hopefully we have success sooner rather than later. Whoops. So 3x minus the 1 for the 1/3. 3x cubed, 4x squared. And here we go. 3x and the 3x cubed will be x squared. That'll be 3x squared cubed minus an x squared. Subtract. We will add opposites instead. 5x squared. 3x and the 5x squared would be a 5x, or a 5/3 x. That's not going to work. Go to the next one. 3x plus 1. Why does that keep going up so far? There we go. 3x and the 3x cubed will be an x squared. X squared times the 3x times the 1. Subtract, but add opposites. 3x squared. 3x and the x squared, I need an x. Subtract, but add opposites. -8x. 3x and -8x, you're looking at -8/3. That's not going to work. 3x minus 2. I'm having some bad luck. 3x and the 3x cubed would be an x squared. X would be minus 2x squared. Subtract, but I'm gonna add opposites instead. That gives me 6x squared. 3x and the 6x squared will be a positive 2x. That'll be 6x squared. Take away 4x. Subtract, add opposites. That's going to give me a -3x plus 2. And that is -1. There we go. So 3x minus 2 worked. Just took 7 divisions. 3x minus 2 which gives you the answer 2 over 3. And the depressed polynomial was what? X squared plus 2x plus 1. X squared plus 2x minus 1. X squared plus 2x minus 1 does not factor. So I was hoping for lovely binomials. This last thing is going to be that x squared plus 2x minus 1. If that was a plus 1, we could factor that. Okay, I'm going to do Lawson quadratic formula. X is equal to a negative b. Your b squared minus 4 times your a times your c over 2a. Negative 2 plus minus. Let's see, that will be positive 8. And that will give me negative 2 plus minus 2 square roots of 2. And I can factor, or I can cancel out a 2, negative 1, plus minus 1, radical 2. Negative 1 plus minus radical 2. Was that right? Yes. And there you go. Now, if you had your technology and you were able to check this, here's how I would do it. I would take negative 1 and plus the square root of 2, and I would store that as my x, and then I would type out the original problem, hoping I get a 0 or something that is equivalent to a 0, and that happens. Hot dog. And you don't have to check them both because of the conjugate root theorem that says answers like that have to come in pairs. Hey, have a nice day. Clean your rooms.